The leak might not be a hacked database. It might be the answer your AI app helpfully writes. That is OWASP LLM02, Sensitive Information Disclosure. In plain English, the model or the application around it reveals information it should not reveal. OWASP's list is broad on purpose. PII, financial details, health records, credentials, legal documents, confidential business data, proprietary source code, even unique model training methods. The mental model is simple. An LLM app is a window into whatever it can see. If it can see a prompt, retrieve documents, logs, system configuration, training data, or a backend API, then output becomes a possible exit door. That's why this risk is bigger than do not paste secrets into ChatGPT. Although yes, please do not make that your security program. The first leak path is user input. Cybernews and Fox Business both reported that Samsung employees allegedly pasted sensitive company material into ChatGPT, including source code. That's the obvious version. A person gives the model information the company never meant to leave the building. The second path is application context. A business chatbot may retrieve tickets, emails, customer records, or internal docs. If access control is too broad, the bot can answer with somebody else's data. OWASP gives exactly that kind of scenario. One user receives another user's personal data because sanitization was inadequate. The third path is training data. If sensitive material enters training or fine-tuning, the model may later reproduce or expose pieces of it. Wired reported a research example where repeated word prompts could push ChatGPT into emitting memorized text, including code, names, email addresses, and phone numbers. Wire also said its own later test did not reproduce that behavior and triggered policy flags. That detail matters. The risk is real, but the exact behavior can change. The fourth path is model behavior itself. OWASP cites proof pudding, a case where researchers built a copycat email scoring model and used its insights to bypass controls. AVID describes that as evading Proofpoint's email protection system by learning enough from a copycat model to craft messages with preferable scores. So sensitive disclosure is not only the model printed a password. Sometimes the leak is structure, scoring logic, training patterns, or enough signal to reverse engineer decisions. Now, the tempting fix is to write a system instruction, never reveal secrets. Helpful, but not a seatbelt, airbag, and locked garage all at once. OWASP explicitly warns that these restrictions may not always be honored and can be bypassed by prompt injection or other methods. Defenders need controls around the model, not just inside the model. Start with data minimization. Do not put sensitive data into prompts, logs, fine-tuning sets, and take care with APIs and third-party integrations. Or retrieval indexes unless the application truly needs it. Then enforce least privilege. If the user cannot access a record, the AI app should not retrieve it on their behalf. Sanitize and redact before processing. OWASP calls out scrubbing, masking, tokenization, and redaction as ways to reduce what sensitive material reaches the model. Harden the plumbing. OWASP's API security guidance warns that misconfiguration can leak sensitive user data, stack traces, cacheable private responses, and system details. Monitor output like egress. A model response is not just text on a screen, it is data leaving a controlled environment. And be honest with users. OWASP recommends clear policies for retention, use, deletion, and opt-outs from training. Privacy techniques can help too. OWASP lists federated learning and differential privacy, but those are supporting controls, not magic dust. The Defender takeaway is this: map what the model can see, reduce what it can see, and inspect what it says. LLM02 is really a permissions problem wearing a chatbot costume. The model is new, the rule is old, secrets need boundaries.